Hello everyone, welcome back to this channel. We are studying class 10 science in that chapter number 12 electricity. So today in this video, which is probably the last theoretical video of this chapter, we are going to study heating effect of electric current, Joule's law of heating and electric power. So electric power will be the end of the theory topics. So let us start with what we have previously covered and covering with the next topic of that is effects of electric current. Now we in the previous videos or also in the previous standards we have learned that there are many effects of electric current which may include magnetic effect, chemical effect, and finally heating effect. So all these effects can be produced by electric current, but in this video we will specially talk about the heating effect. So what is heating effect and how does it produce? When electric current is passed through a high resistance wire, the resistance wire becomes very hot. That means it produces heat, and this is called heating effect of electric current, because due to electric current only there is heat produced in the wire, right? But what exactly is happening in this effect? The electrical energy is being transformed into chemical energy, and that is only and only due to the wire has a very high resistance. Okay, now just for an example, an electric fan becomes warm if used continuously for a longer time. This applies for all the machines as well, right? If any machine is run for a very long time, it becomes warm or hot. That is heating effect. But scientists have thought that let us utilize this heating effect because ultimately it was being wasted, right? We only want a machine to work, but we don't want that it becomes warm because warming will produce heat which is of no use. But then we invent devices like electric iron, toaster, heater, which works on this principle, and this is a very nice principle so that we can use electricity to produce heat. Now let us derive the formula of Joule's law of heating. Joule's law of heating is nothing but a relation between current, resistance, time, and so on. Right? So it is not actually a law of heating, it is actually a relation or an equation or a formula. Okay, that gives us the amount of heat energy. So how does it help? Joule's law helps us to calculate the amount of heat produced, and it will be very easy to design some equipments which are working on heating effect of current, because we need heat from these instruments, but we need to control the amount of heat, right? So now let us go for the derivation. Consider a conducting wire, a resistance wire, which is resisting the flow of current. So to make the current flow we have to do some work. Okay, there must be some potential difference. Let current I flows through a conductor of resistance R for time t when an electric charge Q moves against a potential difference V. Now these are all the few basic phenomena that we have already learned, so we shall assume it before deriving any relation. So current is I, resistance is R, time is t, electric charge Q is moving, and against the potential difference V. So we all know from the previous formula that what is potential difference V? It is W upon Q. So if we do the cross multiplication, W will be Q into V. Now this work done is only the converted heat energy, right? This work done against this all the effects, this all potential difference, resistance, time, current. So this work done will be nothing but the heat produced. So now let us try to replace this Q and V from the previous known concepts. So we know that current I is Q upon T. Current is charge upon time. So from this, can we get a formula for Q? Yes. take the t on the left hand side and it will become q equals to it, and then we shall replace it with the original equation. Now what about v? That is potential difference. So we will use Ohm's law over here and we will write V equals to IR. So these two things that we have just obtained, Q equals to IT and V equals to IR, will keep this value of Q and V over this equation. Okay, W equals to Q into V. So now putting the values of Q and V in equation W equals to QV, we get W equals to, instead of Q I have written in the bracket I into T, then we have multiplication dot, and then instead of V I have kept I into R as per Ohm's law. So I is repeated two times, T and R are one time. So what will be our final formula? W equals to I square R T. So this work done is nothing but the heat energy which is produced when current I flows, when there is a resistance R, and up to time T. So this W equals to I square RT is formula of Joule's law of heating. So Joule's law of heating is very important formula because it gives us the amount of heat produced, right? So already I have written two applications, so you will understand why we are deriving the formula. Okay, moving on to the next topic. In the next topic we have practical application of heating effect, right? So we will see few examples in which we are actually using the heating effect. The first one is a very simple device which is called electric bulb, right? Now what is the basic principle of electric bulb? We get light from electric current, okay, but along with light we also get heat. So let us see what is there in electric bulb. An electric bulb has a filament made up of tungsten. That filament is the spring structure that you can see inside the bulb. This tungsten has a very high resistivity, right? Because we need to produce something from the wire, we must select a material which is having high resistivity, right? And whenever electric current passes from this wire of tungsten having very high resistivity, what happens? The electric current is converted into two things. Main is the heat and some part is converted into light. But do we use heat of electric bulb? No, we do not use it because it is dissipated. It is lost in the environment. So the only part that we are using is the light. So electric current is converted into heat and light. Heat is being wasted, light is being used, right? Now if heat is produced and the bulb is made up of glass, the glass will easily melt or break. So we need to do something for that as well. So the filament is thermally isolated because we are filling the bulb, the inside of the bulb, with inactive nitrogen or argon gas, right? So what happens? The heat which is produced in the filament doesn't affect the bulb, okay, and it lasts little bit longer. Now some more applications of heating effect. You can see this one. What is this? Another hint. We have two pictures over here. One you might not have seen this one, but this one is common in our main electric board of our houses. Yes, this is electric fuse. Electric fuse is used as a safety device in household circuit, and it is based on nothing but the heating effect of electric current. Now this fuse is connected in series connection. Remember, fuse is connected with series connection with the main supply. You can see in your home electric board as well. A fuse consists of an alloy of lead and tin which has an appropriate melting point. This appropriate melting point means that it will only melt when more than required amount of current is passing and heating effect is produced. Otherwise, in the normal condition, this wire will remain intact and all the current will flow very nicely. You can see this wire. Okay, so it is connected in series connection, so whatever current is coming in all the appliances will come from this fuse. Oh, right, we'll go through this fuse wire and then it will go in the house. Now we have electric fuses of different ranges and ratings. For small appliances we have ratings for less current, right, like 1 ampere, 2 ampere for light appliances, and for heavy appliances we have different ratings like 5 ampere, 10 ampere fuse, right. So different ratings of fuse are available. Now what happens actually when the electric current flowing through the circuit is exceeding the safe limit, when it goes beyond normal, more than required, what will happen? That heating effect will be produced. And we have already selected a fuse wire which is an alloy and which will melt if little bit also heating effect is produced. So due to high current, heating effect is produced and the fuse wire will be melt, right? And if it melts, it breaks. And we all have studied that if the electric circuit wire is breaking, it will break the whole circuit, so current will not flow. All the appliances and electric gadgets will stop. So that means that if more than required current is coming in our house and before it will damage the electrical appliances, it goes through fuse, and the fuse is very protective device, it will melt instead of damaging anything. So that is why fuse helps to protect the circuit elements from the hazards which is caused by heavy current. Remember, we have electric appliances worth thousands of rupees and lakhs of rupees. So if heavy current goes inside and damages that, it will be a huge cost. So instead the fuse is damaged, stopping all the heavy current. So that is why fuse is very helpful. Now the next picture will tell you how it works, right? You see, the heavy current is passing and it will create a spark, and you can see that a little spark is created, melting the fuse wire, and thus the current stops over here before going to the appliances and damaging it. Clear? So this is the simple working of electric fuse. Moving on to our last topic, that is electric power. Now, electric power is the amount of electric energy consumed in a circuit for unit time. Electric energy per unit time. If W is the amount of electric energy consumed in a circuit in T seconds, then the electric power is given by P equals to W upon T. Now we know that work done will be the electrical energy. It is equal to V into I into T. So just replace this W with VIT. So our formula becomes P equals to VIT upon T. And this T will be cancelled, giving us P equals to VI. Now according to Ohm's law, we know that V equals to IR. So we can also write IR in place of V. So P equals to IR into I is equal to I square R. So you can see there are three formulas of electric power. This is W upon T. If W and T is given, you put P equals to W upon T. Another formula is P equals to VI. If voltage and current is given and you have been asked to find out power, you will use this formula P equals to VI. If in case current is given and resistance is given, you use this formula of power, that is I square R. So these three formulas are nothing but they are the formula for electric power. Okay. Now coming towards the units of electric power. SI unit of power is watt, that is denoted by W. 1 watt power, one of the most important question. As I have told you, there are few special definitions like 1 joule, like 1 ohm resistance. Same way we have a definition of 1 watt power, and that is when 1 ampere current is flowing through a wire having potential difference of 1 volt, then electric power is said to be 1 watt. Okay, 1 ampere current in the potential difference of 1 volt, then power is 1 watt. Very simple. 1 watt equals to 1 volt into 1 ampere. Other units are also there. That means we have bigger units of electric power as well, which is used for capacity of power plants and all. So that is 1 kilowatt, that is 1000 watt. 1 megawatt, that is 10 raised to 6 watt. 1 gigawatt is 10 raised to 9 watt. So kilowatt, megawatt and gigawatt are the higher units of power. We also had fun old and ancient units of power, that was 1 horsepower, and that was 746 watt. But now we are not using it in much many things. Only in electric pump it is used, and in the engine power of the sports car it is used. Okay, horsepower, HP. So, ending our topic with commercial unit of electric power that is used to calculate our electricity bills, that is kilowatt hour, right? Whenever we see our electric bill, in case you haven't seen, you please see your recent or latest electricity bill. In that they have calculated the amount by multiplying some value with the number of units, right? So what is that unit? Actually, it is nothing but kilowatt hour, right? Kilowatt is 1000 watt and hour contains 3600 second, and watt is joule per second. If you cancel second, final value will be 3.6 into 10 raised to 6 joule. So if you are said to be consuming 1 unit of electricity, that is nothing but 3.6 into 10 raised to 6 joule. Or else suppose that you have an electric appliance of rating 1 kilowatt, and if you are consuming or if you are turning it on for 1 hour, so you have consumed 1 unit of electricity. And if GB is taking 4.5 rupees per unit, so for every unit you will need to pay 4.5 rupees. So if suppose you are using 100 units in 1 month, so 100 into 4.5 will be 450. So 450 rupees you have to pay to the government, right? So that is why it is also known as commercial unit. So this was all related to our theory topics. We have ended the theory topics of the chapter electricity. Since starting to the end, I have tried my best to make the proper points in the video. Also, the tough derivations step by step I have explained to make it very easy, and I hope you are making notes very properly. And submissions, I hope you will be doing it very nicely. So that's it for this video. Thank you.